Flashing. Success. Awesome. So I only have about 150 slides, so I hope we can fit that into that So this is me. I'm Eric Schweigert. I manage a team of engineers in Fremont, California. And I split my time between Nanaimo, I think as Nejo had mentioned. And so I'm sort of a software engineer. I wrote the DPAC inspection modules for the Tofino product, the Modbus, OPC, Ethernet IP, and more recently I directed the development of DNB3 and IEC 104 protocols. So I've been doing this for, I guess, just over 10 years now, and I went to school in Nanaimo. So what I kind of wanted to go over today was just sort of, the world today. We see a lot of stuff in the media, and then I kind of want to move into defense in depth and how you can apply it to securing your industrial control system. And then obviously if you are going to segment your network in certain ways, you probably need devices or tools to help you do that. So near and dear to my heart's DPAC inspection, that's kind of my interest. So sort of talk about that and how you can apply it. And then one of the things that I've kind of noticed sort of in the industry is there's tons of devices out there, next generation firewalls, anomaly detection companies, there's companies here talk about that stuff. So it's a bit confusing, I think, from sort of an outsider looking in. So I kind of wanted to talk about sort of a grading scheme and how you would kind of gauge, one person's implementation of some DPI on some protocol versus another's. And sort of where that came from is, how did I kind of go about writing these modules? So why do you care? Why do you need to sort of secure your network? Why is that important? So we see, in the media all the time, there's hackers taking down traffic lights, there's hackers doing massive damage, people are hacking plants, the Ukraine power went down, water treatment plants have been hacked. So this is, we're seeing it in the media all the time. This is just to give you an idea. It's pretty much every day if you're, get a Twitter feed on some of this stuff. So, this is sort of more recent stuff, June 6, 2017, back in March of this year, 3,000 industrial plants were infected with malware. So this is happening all the time. So there must be just hackers, that's all they're doing, just infecting everything, right? And this is kind of the, if you look at, so this is from FireEye, it's just sort of a trend report. So you can see, 2011 Stuxnet sort of came about. The graph continues, so we only have till 2015 here, but you can imagine 2016, 2017, the graph increases, right? So, and these are only the reported vulnerabilities. These are people that are claimed, or are willing to say, I've been hacked, something bad happened to my plant. But the reality of it is that, ICS and cybersecurity is more than just hackers. So if you look at it, sort of the 80% of it is really unintentional. And if you break that down, it's software flaws, maybe the stack has issues in it, there haven't been firmware updates. Another slice is human error. This is just misconfigurations, people putting a device in the wrong place, the ports are misconfigured. Then half of that 80%, so about 40% is malware infection. That could be a contractor comes into the plant, maybe an integrator. His kids are playing on his laptop the night before, unbeknownst to him. They're going to sites they shouldn't be going to. He comes into the plant, hooks up his laptop, and spreads malware in the plant. And then there's the hacker side of it. So this is the intentional, the bad actors. And really half of the intentional. More than half is the disgruntled employee. He's been fired from the company, he's pissed off, he wants to, do something bad, he's a sysadmin, unhappy, he's got the passwords to everything, he knows how all the network's configured. And then, less than 10% are actually related to hackers. So I should mention this is from 2011, so, maybe the data's, a bit off, but I think in general, this is probably, fairly on point. So what is ICS security really about? So it's really about system reliability, reducing downtime, availability. Because if you increase your productivity, you're going to decrease your operating costs. You want to ensure safety in your network. And then a little bit of it is really protecting from hackers. So I think if you're going to improve your reliability in some way, reduce your downtime, you're going to get the benefits of securing your network, from things like hackers. So what are the real primary concerns when it comes to security? So this is from SANS 2017. I don't really like how they've kind of laid it out. It's a bit hard to read. But the number one thing they cared about is ensuring the reliability and availability of the control system. So they don't necessarily care about cybersecurity. They just want their plant to be running. They don't want it to have downtime. The second thing is lowering risk and improving security. And then way down is, meeting regulatory compliance. So you have to think a lot of industries. The only industry I can think of that really forces you to do something is like PT&D, so power transmission and distribution, where they have NERC SIP requirements. You have to meet some specific requirements for your plant or whatever you're trying to do. Whereas like in the oil industry, you can use IEC 62443 and say, well, I've done a pretty good job, but it's not the best. There's no one really telling you that you have to do this. So that's kind of the general sense of the market. So that's 80% of it is really just I want my network up and running, and I want it to be reliable, and I want to improve security, maybe a little bit under there too, but it's really health and safety of the employees. So what does that mean? So users, customers, we should care about cybersecurity, even if they don't worry about the hackers. But really what they care about is what's my budget, can I keep my network available? Is it safe? Is anyone going to get hurt if something goes wrong? And then they're kind of thinking about, cybersecurity. That's just kind of what I've found. So if somebody is trying to do this, how do I secure my network? How do I improve it? Where do I start? I love this picture because it just, you can see someone with their GPS trying to drive somewhere. They go under an overpass and it's telling them to go left. There's nowhere to go. It's like, what do you do? Where do you start? How can you apply some security methodology to your industrial network? So this is also from SANS. This is 2017, so it's pretty up to date. What do people care about that are managing these networks? What are the threat vectors? So the most interesting thing that I thought at the top is devices and things. So what are these things? These are things that can't protect themselves. So what can't protect itself? Well, you think about brownfield installs. They've got these PLCs that have been running for 20 years. Some IEDs or RTUs. Are they going to shut down the plant to update the firmware? It's probably unlikely. So that's what they're really worried about. Internal threats. That's like the accidental stuff. And then the third one on here is the external threats. So this is the bad actors, the hackers. Nation states like Stuxnet. The U.S. building Stuxnet. That kind of stuff. So I thought it was just kind of an interesting thing here. So and when you think about it, even now you see some companies will produce PLCs that have some method of secure authentication. They're adding some authentication mechanism, but the reality is, are people actually updating these PLCs in their network? That's the hope, but I don't know if that's really what happens. So there's this thing called defense in depth. So this really stems from IEC 62443-3-2s, zones and conduits. And I love this because this is, so at the top there's a picture of somewhere in Europe, castles, multiple layers, the king sitting at the top, sort of the castle. And then the bottom picture is in Japan. So they have a moat at the bottom, all these specific layers. So this is really, these two or multiple cultures building the same kind of mechanism. So it's kind of a tried and true way of, securing important things. So there's multiple layers, it's compartmentalized, the more critical assets, the kings and the queens and the royalty are way at the top. So you can think of that as, portions of your network, the kings and queens or your PLCs doing all the work, although obviously kings and queens weren't doing all the work way back when. So this is just kind of the idea, you're learning from the master builders. That's the whole idea of, a defense in depth strategy. So at the very bottom here, we've got our moat. Whoops. Got our moat. There's a wall. Maybe there's some archers that would be shooting down at people trying to get across different segments. There's a higher wall, then there's a gate. You look at the last line is really the castle itself, all the way to the top. So, and the same, in this case. So what they've really done is they've broken their world, if you will, in our case, our network, into these specific zones. And then there's, gates in between saying, from this point, from zone 0 to zone 1, there'd be some guard saying, yeah, you can go to this zone, but oh no, you can't go from, zone 2 to zone 3. So that's the whole idea of sort of zones and conduits in a sort of real world kind of thought process. And the same is really applied to your your industrial control system network. You think, this is your kind of network here. You got the same kind of idea. You got your stateful packet inspection firewalls here. Maybe you have some deep packet inspection device way down on the network. At the top, maybe you've got some VPN. And in between each one of your zones, you have some, network device with some ACLs in it. So the point of this is that, it's not just one device that's solving all the problems. It's multiple devices doing different things. They've got their specific abilities, and they're really breaking down the network. You create specific segments. So that's kind of the idea of zones and conduits, and different firewalls with different abilities can be used or sprinkled throughout the network. So the one thing that kind of comes to mind is that security is not just this one-time event. Things are always changing. New devices are added to your network. You have new people come in. There's some new integrator that's adding new things to their network. IoT devices get added to the network. Externally, there's new, there's new vulnerabilities. CVEs are published all the time. Malware is developed, so you need to react to that and ensure that all your devices are secure. So you need to monitor and adapt. So if you're that person that needs to worry about this stuff, you got to ask yourself some questions. Did I disable my insecure protocols? Did I disable ports? Was Telnet open? Notoriously plain text passwords going across the network. If I've changed things, have I maintained my security posture? Have other people come in and made changes that I know about? Have I updated my system for those things? Do I adhere to specific protocols like 62443 or NIST? Do I need to comply to some specific regulations like NERC-CIP, for the PT&D? So from that, you have this sort of idea of, okay, well, I need to do these things. What do I do? In that other slide, I had a deep packet inspection firewall down at the bottom. So what is deep packet inspection, and how would I use it? Where does it kind of fit in? So in my mind, deep packet inspection can be used really sort of the lowest layer of the network. It's really to protect your PLCs. So DPI, you can think of a standard stateful firewall. You've got your MAC addresses, IP addresses, port information, TCP or UDP. And a stateful firewall, all that's going to do is look at those fields. So if I said, hey, here's stateful firewall, open up port 80. And as long as there's a TCP SYN, SYNAC ACK, session establishment, the packets will go through. It doesn't matter what the TCP payload is. If you send some to the web browser, you could just pad the packet all with Fs, and it would just get let through. So a standard stateful firewall, that's the best it can do. But a deep packet inspection firewall is actually going to look at the protocol. So if you're thinking of something like Modbus, it's going to look at the MBAP header. It's going to look at the specific function codes. It's going to validate length fields. Going to make sure that the packets that are actually going on that session are actually legitimate for that protocol. So that's the cool stuff. So with DPIs, there's sort of some terms that are used. So there's this idea of data plane versus control plane. So the data plane is really your HMI getting data back. It's temperature values. I'm getting 40 bar on some valve, or some boiler is running at this set point. So this is all the data that's coming back. So this is like the user space applications that are running on top of the underlying OS. So that's the actual process data. So in the ICS world, that's your Modbus, Ethernet IP, SIP, Profinet, Profibus, DNP3, Ethernet IP, SIP, all that kind of stuff. And the other is the control plane. So this is your, if you think of like an Allen Bradley controller, it's running control logics version X. So that's the operating system underneath. So, these updates for a lot of these protocols are done on the exact same path. So like Modbus, function code 90 Schneider has, so it's really their vendor-specific function codes, but you can update the firmware using that function code. There's no authentication. If I can connect to TCP 502 and I can craft some packet for function code 90, well, I'm good to go. I can update the firmware. So you can think of this like, a kernel update. So if someone can do that, what's to stop them from, changing a system call, the user space app or the ladder logic's making some call to the kernel. I could just change the system call, have it exfiltrate some data to some IP address that I predefined. So there has to be some mechanism that can differentiate between those data plane packets and the control plane packets. So that's what DPI, at least in the case that I sort of use it or think about it, is the benefit. You can differentiate between those writes and reads. So some common protocols, I kind of mentioned it. So, my process here is I need some way to compare, products that have deep packet inspection in them. How would I go about doing that? And this kind of came from as I was, writing the code for these modules, like how can I best attack this? So there's sort of commonality between a lot of these industrial control protocols. A lot of them, there's a pretty well-defined RFC, Modbus, it's like a 100-page document, whereas DNP3 is like 1,000 pages. So the complexity obviously varies, but there's some kind of commonality between them. So I thought, well, this is a good way that you can kind of validate, different devices. So this is just a Wireshark capture of Modbus. So it's really simple. It's got this MB app header and then the actual function code. So you're looking at, 10 bytes, and then the response is essentially the same. So it's a really simple protocol. But then if you look at something like Ethernet IP, there's a TCP layer. On top of that, it's your Ethernet IP layer. On top of that's the CIP or SIP layer. So this is just from the actual spec doc. So there's a bunch of fields that you'd probably care about if you're going to write some DPI module, encapsulation header. And then on top of that, each SIP message, SIP is on top of the Ethernet IP layer. The DPI has to understand this information. So there's these port segments, logical segments, network segments, all these specific fields that your code really would have to understand. So it's just how it's represented. It's really a bit field, so you can do some bit masking to look at these. I'm just going to go through this quickly just to kind of give you an idea of the complexity of it. So this is just a Ethernet IP SIP packet. So there's a whole bunch of fields that you should probably care about if you're going to write some full protocol compliance DPI engine. And then DNP3, it's really even worse. So, there's CRCs, there's a data link, transport layer, application layer, and then on the application layer, there's these DNP3 objects that can all be set up in a sequence. So, if you're going to write something that's well done, then it needs to really validate essentially all of these fields as part of the DPI engine. And like the other protocols, there's no authentication. So if you can create a session, a DNP3 session, then you're good to go. I should mention, there is this DNP3 secure authentication that's being added, but the same kind of thing with the PLCs or RTUs, like when's the last time they've been updated? When's the firmware coming out, It's not widely adopted, I guess, is the point. So how do you compare? What do you care about, So, there's some semblance of standard structure across all these protocols. There's a length field in all of them, so you can kind of gauge, my buffer's this size, does this packet look good? So what needs to be validated? So you want to ensure, malware, packet fuzzing, buffer overflows, poor implementations are all caught by some, this DPI engine. And if you catch that, you've caught, 80 to 90% of some of the vulnerabilities that, stem from the above. So, I think this is something you can use as a comparison mechanism. If it's covering these, well, it's pretty good. If this device isn't comparing these, well, it's probably not quite as good. So I have 2 slides. This is my rant slide about signatures. So a signature-based approach is really a reactive mechanism. I say that because, say there's some vulnerability that comes out. Well, for you or for McAfee or Symantec or whoever to create some mitigating signature, they have to understand what the problem was. So the problem's already out in the wild. So they're reactionary, right? They have to go and build these signatures to match, and it's really just a one-to-one pattern match. You can create some if it's this offset to this offset and so on, but it's really this reactive mechanism. The other thing is you see like your antivirus software, it's always having to update, get new signature databases. Well, the ICS landscape, you really shouldn't have access to the internet from your control network. So that's really a no-no. So how does that work? Signatures are really built for specific, 1 byte is this. What happens if it changes? What if there's a vulnerability mutation, right? Then the signature is no longer good, so you got to go get the database. So it's this kind of constant thing. So all you're really doing is you're building a blacklist rather than a whitelist. So you've covered this one. Oh, well, what happens if someone does this attack? Oh, we got to make a signature for that. But if you're creating a whitelist, then you're only allowing some little amount through and everything else is dropped. So that's kind of, signatures aren't kind of the best way. The only place that I see signatures being useful is if it's some proprietary protocol where, they're not willing to give you the spec, so you have to, do what you can with a signature. I mean, something is better than nothing, right? But there's got to be a better way. You should kind of do some full implementation. So depth matters. Depth's more important than breadth. So breadth with no depth doesn't have any value. So, saying that, I cover 500 protocols, well, to what extent do you cover them? Are you looking at a specific byte in one packet? Yeah, I have a signature for one thing. Well, it's covered, So there's some products out there that kind of do that. Those are my rants. So what does this mean? So how do you kind of validate this? What are the important things you should look at if you're looking at multiple devices? If you're a consumer, how do you kind of gauge what's better than the other? Not everything's created equal. So, and a lot of these protocols, one thing in one might mean something different in another. For Ethernet IP SIP, there's a length field on some specific, get attribute all. What does that mean? Specific protocols like Goose have these type length value fields. So if it's a specific type, does this length mean something different on this type? So if you're going to write something, you need to really understand it. So a full protocol implementation is really important. So what I've kind of done is come up with these comparison items. So if you have, 6 products, they all do DPI, they all claim they do, X, Y, Z. What can we compare against? So I have this idea of this sanity checking. So that's really, like I mentioned, you're understanding the entirety of the protocol. You've got the RFC, you're going to sit down and write your code to make sure that everything that you see is actually part of the protocol itself. It's not a signature, it's validating everything. So this, for me, this is important. If you have some device that's going to say, I'm doing DPI, well, it better do this. It better at least do this. So that's my first comparison item. The second one is this idea to differentiate between your control plane and data plane actions. So this is like, I want to read data, but I want to drop it. So if you had a stateful firewall, say you got Modbus traffic, I don't want to do any writes. If it's a stateful firewall, what do? You block 502. Well, then your HMI can't grab any data, so what's the point, right? It's not useful. So you need to be able to differentiate between these write commands and these read commands. So I kind of call this my action filter once. I'm going to allow firmware update from these IP addresses. I'm not going to allow it from, these other specific IP addresses. So that's what the DPAC inspection is really giving you. And if some product is doing this, it should really understand this. So that's like my second comparison item. So the third one is about state checking. So on top of TCP, or maybe it's a UDP-based protocol, you need to have some way to correlate your request with responses. If you have 2 requests, did you have 2 responses come back? Was there actually a request for this response? So it's just to make sure that the protocol is running as it should. So the fourth one is about response packet validation. So this is really important for DNP3 because there's a bunch of vulnerabilities that are actually going from the PLC or the RTU back to the HMI software. So Crane and Systrom had published a bunch of these a few years ago. So if you're not validating that, then I guess some of them, what they were doing was they were sending back false data to the HMI, and the person, sitting way away, because DNP3 is used with substations, PT&D industry, so you'd be sitting in his HMI, oh, the data looks good, but the reality is, the substation's actually offline. So response validation is really important to make sure that, you're not sending the RTU or an IED is not sending back incorrect data to the HMI. So this is vendor-specific stuff. So, if your plant's all Rockwell plant or your plant's all Schneider plant, then maybe knowing vendor-specific portions of that protocol are important to you. So you'd probably kind of gauge, well, this product can do this better than some other product because it's covered my, PC Cube from Rockwell, or it covers Schneider. So that's kind of, you could gauge it that way. And then finally, pipeline messages. So you'll see this with TCP retransmissions with Modbus. What will happen is you'll have some read message, and you have a write message, then another read message. So if someone was smart, a bad actor, they could just put a read, then some write in there, and then another read. So if your DPI engine's not actually iterating through all of the packets, well, that'd be a great attack. So, this is important to actually validate the pipeline-specific stuff. What I did was I kind of came up with some sort of grading scheme. So, quantitative is always nicer than qualitative. So having some numbers, you can kind of gauge, this product can do this, it's got this value, maybe 14 out of 21 is really great compared to, the other product that, it's got ones in the whole field, so it's got 6 of 21, so, it's just kind of something that I came up with to try to grade devices, so, but I mean, what really constitutes these values? So in the case of sanity checking, a 4 of 6 means that maybe you're only covering a specific set of it. So I was looking at, so function code 15 for Modbus, write multiple coils, maybe it's only looking at the function code, maybe it's looking at the starting address, it's not even looking at the quantity of the coils, or maybe it's looking at the quantity of the coils and just looking for 7V, or maybe it doesn't even do validation checking on the full range. So, it's really kind of a subjective thing. You could gauge it differently as you're going along. A 6 for me would be like, yeah, we cover every single packet. RFC is like a mirror of the code, so it's really validating everything. So in the same kind of deal, action filter, to what extent is it actually validating things? So DMP3 was a great example of this just because of the complexity of the protocol. There's this application layer function code, so you have your like select, direct, operate, those kind of things, and then further down in the packet you have these DMP3 objects which have the group number variation function code, qualifier code. So if your code can actually validate, the application layer, it also gives the ability of the user to pick and choose group numbers, variations, then it's really kind of this complete implementation. So for me, that would be like a 4. And you could obviously change your grades. You could make it from 1 to 10 to be more granular, just depending on what you're trying to do. Some of the thoughts with this, it's kind of hard to gauge depth. And this is because if you look at marketing literature, it's not going to tell you how it's implemented. So if you could do black box testing, well, if you have the same test set, for 6 different products, you could probably say, well, this one covers, 80%, this one covers 20%. Well, that one's terrible, and the other one's a lot better. So it's really, it's sort of hard to do that, if you have the time. But from the average sort of user or customer, they don't have that ability. So it's kind of unfortunate. The numbers, like I mentioned, are a bit subjective. You could kind of change it how you want. And also you could compare, this is an implementation using signatures versus some implementation that's actually sort of full protocol conformance, or if it's a proxy. The depth of the implementations may differ within the product itself. So maybe they really have, great Modbus implementation, but have a really poor DMP3 implementation. So it makes sense probably to compare protocol to protocol instead of product to product. And maybe one product does something better that you care about more so than some other product you don't care about. Maybe it has vendor-specific actions that are worthwhile to you. So other elements to consider. So a DPI engine that supports everything but has an awful interface is really not very useful. If you can't configure it, what good is it? You're always talking to tech support, well, it's not very useful. And then the other thing is, okay, you validate some poor packet or bad packet, it's some bunch of F's at the end or something, what do you do with it? Do you drop it? If it's TCP, do you send a TCP reset to both directions? Do you send a message to some SIM, some syslog server somewhere? These could be things that you could add to the scheme. And I didn't talk about throughput or latency because it's really about the implementation itself. But for some protocols like Goose, latency is really important. It's using VLAN ID 0, so it's like latency is something you'd have to think about. And the kind of final thing is not all DPI implementations are created equal. That's something to keep in mind. So I know I kind of jumped through 2 different things here. So I think defense in depth, it's sort of a time-proven thing. It's been around for ages. There's obviously ISA, IEC 62443 really goes into detail about this. DPAC inspection can play a useful role in protecting these devices that can't protect themselves. So it gives you the ability to differentiate between the data plane and the control plane actions. So I think that's important. The other thing is security is, it's ongoing. Stuff's always happening. There's new vulnerabilities that come out. Really need to be proactive in understanding what's happening in your network. There's really no one-stop shop to secure your network. There's a whole bunch of pieces that you can put together to help you secure your network. Questions? Yeah, go ahead. Yeah. Yeah, I mean, that's a great question. So I think, this is one of the problems, other than like PT&D, where they have NERC SIP to really force regulations into some, the like oil and gas, which is really where I spend most of my time. There's no regulations, so it's really, one customer is really educated, they understand ICS, they're looking at, what are some standards that I can use as kind of my baseline and where I can gauge, and then, there's other customers that just have no idea, they don't know where to start, so they're that other picture. As far as IoT is concerned, yeah, I mean, I think this is the same problem, is that there's no sort of governing body, I guess, and even if you go from country to country, there's differences. There's this whole Industry 4.0 stuff going on in Europe right now, trying to push different regulations, and I think there really needs to be, if there's no regulation, then it's really, I think, the will of the company to try and protect itself. So I mean, it all comes down to money, right? So if they realize that if I protect my network and it won't go down, well then maybe in the long term I've saved, a certain amount of money. It's kind of like insurance, right? If you have it, you need it, it's awesome. If you needed it and you didn't have it, then it's going to cost you a lot, right? But people don't always necessarily realize that. I don't know if that answered your question, or that's a tough question. Anybody else? Okay, thank you.